Hello, this is ESPIN Adam. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service. Docker and Application Container, Challenges and Future Trends. Docker includes exploring differences between application containers and virtual machines, challenges, and future trends in container security. Here are key takeaways from this topics. Evolution of containerization, rise of Docker. Docker, launched in 2013, is an innovative, open-source platform that revolutionized the way applications are developed, deployed, and managed. Why Docker gained popularity. 1. Portability. Docker containers are designed to run seamlessly across diverse environments. As long as the Docker runtime is present, the containers operate consistently. 2. Efficiency. Docker containers significantly reduce resource consumption compared to virtual machines. 3. Scalability. Docker excels in environments where applications need to scale horizontally. Its ability to spin up multiple container instances rapidly makes it a preferred solution. For scalability, Docker ecosystem is enriched by Docker Hub, a centralized repository for container images. Understanding application containers. Application container is a standardized, lightweight unit that packages an application along with its dependencies. 1. Lightweight. Containers share the host OS kernel. This minimizes resource consumption, allowing multiple containers to run on the same system without significant overhead. 2. Immutable. Once a container is built, its configuration, application code, and dependencies are locked in place. 3. Isolated. This separation prevents interference between containers and enhances security by limiting the impact of potential vulnerabilities or errors. Virtual machines. In contrast, virtual machines is a complete emulation of a physical computer, designed to run its own fully fledged operating system and applications. Key characteristics of virtual machines. 1. Resource intensive. It provides a comprehensive environment for applications requiring robust resources. 2. Robust isolation. This OS-level separation provides strong security boundaries, making VMs particularly suitable for workloads requiring stringent isolation. 3. Flexibility. Provide to run multiple operating systems like Windows, Linux, or others on the same physical hardware. This makes VMs an excellent choice for scenarios requiring cross-platform compatibility, testing, or legacy application support. Security challenges in application containers. 1. Shared kernel vulnerabilities. If the host kernel is compromised, every container running on the host is potentially at risk. 2. Isolation breaches. A vulnerability in the container runtime can allow attackers to escape the containerized environment and gain access to the host system. 3. Untrusted images. Unverified or untrusted images may contain malware, backdoors, or outdated software components with vulnerabilities. For secrets management, if a container is compromised, these secrets can be exposed to attackers. 5. Orchestrator risks. Misconfigurations in orchestrators can expose critical components, enabling attackers to compromise containerized workloads. Role of application container security platforms. Key features of application container security platforms include 1. Image scanning. Security platforms perform thorough scans of container images to detect vulnerabilities, outdated libraries, and malicious code before deployment. 2. Runtime protection. Focuses on monitoring container activity after deployment. Security platforms continuously analyze behavior within the container environment to detect and mitigate anomalies. 3. Access control. Authorized users and systems can interact with containers and orchestrators. 4. Network segmentation. By restricting communication between containers and external systems, they reduce the risk of lateral movement by attackers within the network. 5. Compliance management. Security platforms automate compliance checks and generate reports to demonstrate adherence to frameworks. Popular application container security platforms. 1. Aqua Security, leading security platform designed specifically for containerized environments. It provides comprehensive tools for securing the entire container lifecycle, from development to production. 2. Twistlock, now a part of Palo Alto Networks, is a comprehensive security platform for containers, Kubernetes, and cloud-native environments. It provides end-to-end security with features for vulnerability management, compliance, and runtime defense. 3. Sysdig Secure combines security with deep monitoring capabilities to deliver detailed insights into both container performance and security. It allows organizations to secure containerized applications. 4. Anchor focuses on container image analysis, offering deep vulnerability scanning and policy enforcement. Its platform allows organizations to assess container images for potential security flaws. Best practices for securing application containers. 1. Use trusted images. Always pull images from trusted sources or create custom images to minimize risks. Example, only use images from official, trusted sources or well-known repositories. 2. Regularly update images. Keep container images up to date with the latest security patches. Example, regularly check for and install patches from image vendors. 3. Implement principle of least privilege. Grant containers only the permissions they need to function. Example, run containers with the least privileged user, not as root. 4. Scan for vulnerabilities. Employ automated tools to scan images and containers for known vulnerabilities. Example, use automated vulnerability scanners like Claire, Trivy, or Anchor to identify issues in images. 5. Isolate containers. If one container is compromised, it cannot easily affect others or the underlying infrastructure. Example, use Docker namespaces, groups, and other isolation mechanisms to isolate containers. Future of containerization and security. 1. Integration of AI and machine learning. Enable security tools to detect sophisticated attacks and anomalies in real time. 2. Enhanced orchestrator security. Focus on strengthening the security controls within Kubernetes and similar systems to protect against new attack vectors. 3. Zero Trust architecture, ensuring that access is strictly controlled, monitored, and limited to the bare minimum necessary for operations. 4. Policy as code. Organizations can enforce security controls at every stage of the software development lifecycle. Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.